Good day, students. In today's class, we'll be talking about rate law and order of reaction. In the past videos, we've established that rate of reaction talks about the change in concentration of a reactant or product with time. Now, have you ever asked yourself that how can we make a reaction faster? I know we have some factors that affect rate of reaction, like temperature, like concentration, like pressure, and all that. But still, how can we make a reaction faster? It was discovered experimentally that an increase in the concentration of a reactant can cause an increase in the rate of a reaction. Take, for example, we have a reaction again. I love using A equals B. I think it's very, very easy. A equals B. Now, the reactant here obviously is what? Is A. This is the reactant. Now, let me assume that the rate of this reaction is let's say 1.0 molar per second. So that means that every second, 1.0 molar of the reactants is being used up. Now, can we increase the rate? Can we increase the amount or the amount of concentration that will be used per seconds of the reactants? Can we increase the rate of this reaction? Now, it's simple. For us to make the reaction faster, for us to increase the rate of this reaction, all we simply need to do is to increase the conc of the reactant and not the product. By increasing the conc of the reactant, we can increase the rate of the reaction. This tells us that the rate of a reaction is directly proportional to the concentration of the reactant. This here is what we call rate law. So rate law simply states that the rate of a reaction is directly proportional to the conc of the reactant. Please don't make mistake in this, not product, but what? Reactant. That means that the rate of a reaction depends on the concentration of the reactant. Now, it's not always so. It's not always so. There are some reactions that even when you increase the conc of the reactant, it will not affect the rate of the reaction. Don't worry, we're coming there. We're going to talk about that in later videos. Okay, but generally, increase in conc of a reactant may increase the rate of the reaction. So we call that concept or that law, we call it the rate law. So going back to our equation where we have A to give B, okay, as I said earlier, for me to increase the rate of the reaction, I simply have to increase the conc of the reactant. So I can write this as R for rate is equal, sorry, not equals to, is directly proportional, right, to the what? To the concentration of the reactant, which is what? A. Okay, so removing the sign of proportionality, what are we going to have? We're going to have R equals to, bringing a constant. The constant here is K. So R equals to K conc of A. And the thing here is that the concentration of A is going to carry a constant, a power. Okay, let's call the power, let's call it X. Let's call this X. Now, note something, that this power here is not the stoichiometric coefficient of the reactant. What I mean by that is this. Let's take, for example, I have 2A to give B. If I ask you what is the rate of the reaction or what is the rate law, it is wrong for you to tell me that the rate law is equals to R, that's R equals to K conc of A raised power 2. This is wrong, although it might be correct, but it is wrong to assume that the coefficient of A, that's of the reactant, is the power of that conc. No, it's wrong. Okay, so we determine this power here, we determine it through experiment, and not through mere looking at the reaction. Do you understand? So that's why I used X. I didn't use 1. I just used X just to tell us that, okay, we can't know it except we perform an experiment. So this number up here, this number, that's this unknown number this number X is called the order of the reaction. So in this reaction now, this is I can say this is X order of reaction. Okay, let me assume I have an elementary reaction. I'll explain that in the next videos. We have A to give B, and let me assume that the rate law, okay, that the rate law for this reaction is R equals to K conc of A. raised power 2. Let me assume that this is the rate law. Let's just say this is the rate law. Now, what can we use this rate law to determine? We can use the rate law to determine about three things. One, we can determine the rate of the reaction. Two, we can determine the value for K. K here is called the rate constant. We will solve examples in the next video. Rate constant, okay? And these two here, very, very important. We can use the rate law to determine what? To determine the order of the reaction. If it is in first order, second order, or third order. So basically, I gave you just three uses now of rate law. We can use rate law to determine what's the rate of the reaction, the rate constant, and also the order of the reaction. So from this, my example, the order of this reaction, the order is what order? Is second order. We don't say two order. We say second order. Okay, take for example that the rate law of a reaction, let's say the reaction is B to give C plus D. Don't forget, we don't have any business with the product, okay? So let's assume that the rate law R is equals to K conc of B raised power 1. This is the rate law. Let's assume this is rate law. Then I ask you a question. What is the order of this reaction? The order of this reaction, you don't need to crack your back or or stress yourself to calculate this. It's simply the power you are seeing here. Whatever you are seeing here is the order. So the order of this reaction now is what order? Is first order. I think this is quite clear. Okay, let me assume I have, in these examples, I have only one reactant. Let me assume I have more than one reactant. For example, I have A plus 2B to give C. Let me say C plus 4D. Let me just play with that. And I say that the rate law, don't forget I said we determine rate law, okay, through experiment. I'm just assuming, okay. In next videos, we're going to solve questions. I'm just assuming what the order is. You don't assume, you have to solve, you have to perform experiments. Let's assume that the rate law of this reaction is K conc of A, okay, raised power 1 times conc of B raised power 2. Let's just assume that this is the rate law. This is the rate law. And the question now is, what is the order of the reaction? What is the order of the reaction? So you might be confused that I said that the order of the reaction is the power on each of the conc of the reactants. But now we are having two reactants. So the order of the reaction, very simple. It's just the addition of the powers of the reactant. So that means the order of this reaction is what? 1 plus 2, which is what? 3. So that means the order of the reaction, this reaction is in what? Third order. But you can ask you a question now, what is the order of the reaction in respect to A? In respect to A, the order of the reaction is in what? First order. While in respect to B, order of the reaction is what? Is in second order. But in the overall reaction, the order of the overall reaction is 1 plus 2, which is what? Third order. Lastly, let's assume I have a reaction like this. I have, again, A plus B plus C to give D. And I say the order of the reaction, the rate law is R equals K conc of A raised power M times conc of B raised power N times conc of C raised power O. So what is the order of this reaction? The order of this reaction, the order is what? M plus N plus O. As simple as that.